So let's have this sample exercise taken from the Statistics and Probability book of Belicina, Baca, and Mateo. So an admission officer of an educational institution wants to know the age of all entering mathematics majors. He computed a mean age of 18 years and a standard deviation of 1.2 years on a random sample of 25 entering mathematics purportedly coming from a normal distributed population. With 99% confidence, find the point estimate and interval estimate of the population mean. So let us try to write down first the given values. So we have here the given values. We have our sample mean, which is 18, and our standard deviation, which is sample standard deviation, which is 1.2. Our sample size is, we have a random sample of 25 entering mathematics major. So n is equal to 25, and our confidence coefficient here, confidence coefficient is 95%. Now our alpha is going to be equal to 1 minus the 0.95, because our confidence coefficient is 95%. So this is going to be 0.95. So our alpha, it's 99. Sorry, this is 99%. So this will also change. This is 99.99, and we have here 0.01 as our alpha, or level of significance. Now the first question here is for us to find out the point estimate, and we know that the point estimate here is our sample mean. Again, the point estimate is a specific numerical value of a population parameter, and the best point estimate of the population mean that we have here for this example is going to be our sample mean. So our point estimate, so that's letter A, point estimate is going to be equal to our population mean, which is equal to 18 years old, or 18. Now, the second question is for us to find out the interval estimate of our population mean. Okay, interval estimate. Now, to find the interval estimate, we have to make use of the formula that we just learned under t distribution, which is this one. Let me just upload, attach it here. And so this is the formula that we're going to use for this example. The t distribution, the fact that the sample size is less than 30. At the same time, the population standard deviation is not given, because we're looking at a random sample of 25 mathematics major, entering mathematics major. So we have this formula for estimating our population mean with our n is less than 30 to find out the interval estimate, or the confidence interval. Now, so let's try to write here try to substitute the values. Now, we have the sample mean, we have the sample standard deviation already, we have the sample size, we have the level of significance, 0.01, we have the confidence coefficient already, 99%. What we need here is basically the critical value or table value for the test statistic t. Now, what are we going to consider here for us to be able to find the table value for the test statistics t? Very crucial is the degrees of freedom. Here, I'm going to write it down, okay? Degrees of freedom. And the degrees of freedom is equal to n minus 1. So in this case, n is 25. So df here is going to be 24. We need this later on, because when we are going to check our t distribution table, we have to consider the degrees of freedom for this example, which is equal to 24. Now, let me just make this much clearer. So this is going to be D. Okay, and so now we have to find out T alpha over 2 for this problem. Now let me just allow me to insert the image of our T table for us to be able to identify the value or the table value for the test statistic T, or our critical value. Okay, before we will start how do you call this one, like substituting the values in our formula. Now our DF is 24 and our level of significance is 0.01. Okay, 0.01. So let's try to check the intersection of our level of significance 0.01 and our degrees of freedom 24. Now we have to consider here that for this case, this is like since we're looking at the interval estimate, so this is going to be under the two-tailed test, because there's going to be two values that we will need. One is going to be below the mean, which is going to have like a how do you call this one, a value which is negative, and also the other one is going to be above the mean, which is the value is going to be positive. Now let us let's try to use this and let's try to locate level of significance for two-tailed test. So 0.01, intersection of 0.01 and our degrees of freedom 24. So this is going to be 24. So this is our let's try to 24, sorry, 20 here. We have this one 24 and 0.01 is somewhere there, somewhere. Okay, intersection of our, sorry, it's just, oh, sorry, it's this one. Okay, so that's it. This is basically our, what we need here is, sorry, this is the table value for the test statistic T is 2.797. So let me just write it here so that we'll all be guided. So T alpha over 2 is going to be 2.797. Okay, 2.797. So now we can already how do you call this one? We can already just erase this. We can already start substituting the values here. Okay, so let's have, we're going to have two values. One is going to be negative, so this is going to be negative and positive 2.797. okay, it's equal to negative 2.797. now let's try to substitute the values. So we have here, so sample mean minus T alpha over 2, then we have here our standard deviation is 1.2, sample standard deviation 1.2, and we have here 25 as our sample size. Okay, then we substitute the values. This is going to be 18 minus 2.797, then we have here 1.2 all over square root of 25. Then on the other side, let's have like sample mean plus T alpha over 2, then we have here our S all over square root of n. Sorry, this is let me just change this first. This is S, this is S all over square root of n, and we have also here, so let's substitute the values here. We have 18 plus 2.797, then we have 1.2, sorry, it's 1.2 all over square root of 25. Then using our calculators, okay, just get your calculators and let's try to let's solve this. We have 18 minus 2.797. Then we have here also 1.2 all over square root of 25. Let's try to, it's the answer. So this is like 7.33, approximately 17 point, so approximately 17.33. And the other one, the other side is going to be, it's approximately 18.67. Okay, that is going to be the, that's going to be our answer already. Okay, now we have to write it in complete sentence. So this is going to be therefore, or ergo, or therefore, we can say with we can say with 99% confidence that the interval between 17.33 and 18.67 contains the true mean age. Contains the true mean age of the population, population of entering mathematics majors based on the sample, sample of 25. Okay, so we can say with 99% confidence that the interval between 17.33 and 18.67 contains the true mean age of the population of entering mathematics major based on the sample of 25. So this is our, that's our final answer. Okay, and